It is August 28th, approximately 8:37 a.m. And today we are going to be getting into artificial intelligence through the work by Russell and Norvig, starting with chapter 1, which is Introduction to Artificial Intelligence. Okay, so the historical context of this: humans have long asked how the mind works. Aristotle studied reasoning rules. Our basic understanding of fallacies and biases can be traced to him. Logic, meaning an instrument of rationality separating chaos and order in a sense. But Alan Turing reframed the problem in 1950. Instead of asking, can machines think, he asked if a machine could imitate human conversation well enough to fool an interrogator. Yes. So this thought experiment became the Turing test, the famous Turing test. So there's some definitions of AI. So approaches differ by whether they emphasize this isn't exactly a definition, but emphasize thinking versus acting, and human-like versus rational. And there's an interesting definition in the book which says that rational is defined as right think, but that's kind of fuzzy, right? Right thinking, it's like who determines what's right and what's wrong. But suffice to say, rational, ratio, being the word there, is like a reasoning by steps. It's like 1, 2, 3, 4, 5. You're walking up the ladder to a truth, right? So, it's what is truth, and then that's a more base thing. But so yeah, four traditions emerge, which is we want AI to be thinking humanly, I guess you could say, humanly. Thinking rationally. Which, by the way, these things aren't necessarily, what's the word? Separated. Like, you can have something that thinks humanly and thinks rationally, right? But it's just difference between belief and act, intent and act, acting humanly, acting rationally. So that's that. These are the sort of the four lines that we generally see. Now let's get into something a bit more specific. As AI is a field, right? You can have the thing itself, and then there's the field which studies it. So if we define it along those lines, artificial intelligence is the field concerned with building systems that display behavior we would call intelligent. Scare quotes. If done by humans, right? Camera check. Camera's good. So what are some examples of routines? Well, some things that we could stir into the pot of designing these systems that display these behaviors, right? So core capabilities. So the typical ingredients that we find in an AI system, at least now, is natural language processing, it's the most famous one right now, right? Understanding words. Knowledge representation. Ooh. Storing facts. Automated reasoning. Drawing conclusions for drawing conclusions. Machine learning, also very popular. Proving with experience, which has to do, deep learning was a thing, and it's mentioned in the book. Deep learning this relates to that, which is very cool stuff. Computer vision. Seeing, of course, for seeing. And robotics. Acting physically. And there's some theories that go like you can't possibly replicate, well, I think it's a reasonable theory, you can't possibly replicate human intellect without having some form of embodiment, so this is becoming increasingly important. There's like virtual embodiment and stuff like that, but until you have like something that's as close to real as a human senses things that are real by its own human experience, then, you know, you can't necessarily say that you have something which is isomorphic to, or corresponding to, or roughly equivalent to human intellect. But we'll just shelve that for now and focus on a calculated example of a Turing test. So let me just erase this real quick. So imagine a human judge converses via text with both a machine and a person. If after many questions the judge cannot reliably tell which is the human, the machine passes. Machine must manage. So we have an interrogator. Interrogator. It's supposed to be 2 R's. Interrogator wants to tell if of two participants which is human and which is machine. Right? So machine, the goal Make difference imperceptible. Make a difference imperceptible. So the machine must manage small talk. Which is a lot of human talk, right? Must manage small talk. Breaking the ice, Factual questions. And follow-ups. Which, is something that Ch1 can pretty much do. So, let's get that covered. And requires integration of all 6, which we're not really going to get into, you can look in the book, 6 AI capabilities. Just a sort of walkthrough of this, a judge would ask, what is 2 plus 2? The machine would say 4, which is a trivial case. Judge would say, tell me a joke. Machine retrieves a canned joke. Judge would ask, what did you say earlier about your favorite book? The machine would answer, must remember past conversation equals knowledge representation. So the takeaway of this is passing requires more than tricks. The test stresses memory, reasoning, and flexibility. And within chapter 1, it goes into this long conversation about, whether or not the Turing test is exactly a thing which we view as a valid marker of actual AI, success? So that's an interesting discussion in there as well. So the essence of AI is not copying humans exactly, but designing systems that can act rationally, and that's the crux of the matter, right? And that includes, insofar as we can tell, doing the right thing in context. So that's pretty much it for chapter 1. Again, there's more in the book, and there's a whole bunch of stuff in there, but we'll get to chapter 2 in the next lecture. We'll discuss chapter 2 in the next lecture. There we go.